start with a topic called as arrays. Today we are going to start with a topic called as arrays. So first of all, you need to understand how did this word came into existence, right? So basically, right, this word came into existence from two words, arrange plus ready, right? Ready means organized. So that is how this word came into existence, like array. Okay, arranged plus ready, right? That is how it came into existence. Okay, now, right? So let's understand what is an array first. Okay, let us understand the definition of an array. Okay, so first let's write down array is, right? It is a collection of homogeneous elements, homogeneous elements stored in right continuous memory, right, continuous memory. Okay, continuous memory. Now why we require this concept? See, for example, I want to store two values. So what I will do, I will declare two variables like this. Okay, if I want to store three values, I will declare three variables. All are of same data type. Okay, now if I want to store 1,000 right values, I cannot sit and declare 1,000 variables. Isn't that correct? So that is why this concept comes into picture. That is why this concept comes into picture. What is the meaning of homogeneous? Means elements, right, with same data type, with same data type. So that is called as, right, homogeneous, right, homogeneous elements. That is the meaning of homogeneous elements. And also you should remember that, right, all the elements are stored in a continuous memory. Okay, so basically there are two types of arrays here. Types of arrays, types of arrays. There are two types of arrays, right? The first one is, right, one dimensional array, and another one is multi-dimensional array. Multi-dimensional array. Okay, so basically we have two types of arrays. One is one dimensional array, another one is multi-dimensional arrays, right? Now let us concentrate on right one dimensional array as of now. Okay, let us concentrate on right one dimensional array as of now. Okay, let's concentrate on that. One second. Okay, so let's start with one dimensional array. Let us start with one dimensional array. So 1D array, right? So here what happens is, right, we store all the elements in a sequential fashion, right? And the way we access is sequential fashion only. Now, first thing we need to understand is how to declare an one dimensional array in our C language. So for that, we should know the syntax. So syntax of one dimensional array declaration is data type followed by array name followed by one second now. I'm just gonna shift these things a little bit this side. So first thing is, right, data type followed by array name followed by the size of the array. So this is how we declare, right, one dimensional array. This is how we declare one dimensional array. Now let us take an example, right? Let us take an example, right? Int arr of int arr of 4, right? Int arr of 4. So whenever you declare an array like this, right? So you need to understand what is the meaning of size. So basically, size will tell us, right, the number of elements can be stored into the array, right? If you write the size as, right, 4, the number of elements you can store into an array is 4. So one dimensional array, right, syntax is data type followed by array name followed by the size. So the size will tell us the number of elements. Okay, the size will tell us number of elements. So I have taken, right, the example here int arr of 4. Now, right, how does the memory representation of this, how does the memory representation of this will look like, right? The memory representation of this will look like this. Okay, memory representation will look like this. It's a continuous memory, right? So the array name is, right, arr, right? So how do we access these elements? Array elements are always, right, array indexing. These are called as indexes. So array index always starts from 0, ends at size minus 1. Okay, so these are the array indexes, right? So array index, the first point that we have to learn here is, right, array index always starts from, right, 0 and ends at size minus 1. Size minus 1. So this is the, right, way how we represent an array. It's a continuous memory. So right now I have reserved only, right now I have reserved only, right, right now I have reserved only, right, 4 memories, right? So, right, 4 elements I can store. Now let us take an example here. Let us take an example here, right? So how do we access each memory? To access each memory, to access each memory, right? To access each memory, right? Let's say I want to access the first memory. So how do I access it, right? So to access the first element or first memory, right? How do we write it, right? Arr of 0 is equal to some value you can store. Okay, you can store it with some value, that is 10 will be stored here. Now if you want to access the second element or the second memory, right, you will write it as arr of 1, right? If you assign 20, this 20 will be stored into this memory. Okay, this 20 will be stored into this memory. And if you want to access the third element or third memory, right, so how do we write it? Arr of 2 is equal to 30. Arr of 2 is equal to 30, and 30 will be stored into this memory. Okay, 30 will be stored into this memory. And if you want to access the fourth element, which is the last element, right, so this is how we access that particular memory using the index, that is 3 is equal to 40. Then that 40 will be stored inside this memory. Are you clear on the syntax of one dimensional array and an example? How does the memory looks? Memory representation. Memory representation. Okay. The second topic that we have to learn in arrays is array initialization or initializing 1D array. Initializing 1D array. So now the question comes is how we can initialize one dimensional array. Now first of all, everybody should understand what is initialization. So see here, there are two scenes here. Int a semicolon a is equal to 10. This is called as assignment, right? This is called as assignment. But whereas this int a is equal to 10 is called as initialization. Is called as initialization means, right? Means whenever you store a value into a variable, whenever you store a value into a variable, right, at the time of declaration is called as initialization, right? So let us take an example here. Let's take an example. int arr int arr of 4. This is the size I've given. I'll initialize the entire array with 4 elements. Okay. Now, how does these array elements are stored? Right. These array elements are stored right in the memory represented. Okay. This is how they are right stored. Okay. This is how they are stored in the memory. This is how they are stored in the memory. Okay. Now, the next part that we have to learn is right. The next part we have to learn is right during initialization. Only during initialization, array size is optional. Array size is optional. That means you can skip the array size. You don't have to mention the array size only during initialization, because the array will automatically take the size of the array based on the elements you are storing. Based on the elements that you are storing. Based on the elements you are storing, array will take the size as automatically as 4. Okay, are you getting my point? Okay, so this is about array, right? Okay, now I'll insert something here. Okay, I'll insert something here so that we can practice it. One second. We will write down all the points here. Okay, we will write down all the points. Okay, okay. So the first point what we had written, first point was array index starts from 0 and ends at size minus 1. This is the first point. Second point is during initialization. During initialization of 1D array, right? Size is optional. Size is optional. This is what we need to remember. This is what we need to remember. And also the size what we mention, the size what we mention, the size of array must be constant in C language, right? See, what I'm trying to convey here is, the size what you mention here, like 4. Okay, like 4, this must be a fixed number, right? So here if I take another example here, example 2, right? Okay, i'll I'll write an example as pointwise. Int arr of is equal to 2, 3, right, 4 and 5. One second. Okay, 2, 3, 4 and 5. So these are the elements in the right array. Now you can say that it is optional. The size of the array is optional only during initialization. Now let's go for the third scenario. Example 3. Example 3. Now what we have seen here, int arr, int n is equal to 5, and then I'll declare int arr of n, right, semicolon. Okay, this is error. This is error because, right, because array size or size must be size must be constant. Size must be constant. It cannot change because I have mentioned a variable there. I have mentioned a variable there, so that we cannot do it. That we cannot do it. It must be a fixed number. It must be a fixed number. It must be a constant. Right? Are you getting my point? Whenever you're doing a partial initialization, you look at the size of the array. It is 4, right? But I have initialized the array with only two elements. I have initialized the array with only two elements. So in that situation, the remaining elements in the array will be filled with 0 by the compiler automatically. It will be filled with 0 by the compiler automatically. That is the meaning of this point. Now, continuing. Let's go with the fifth point. Another example. Okay, another example. So, int arr of, right, 4. I'll initialize this array with 4 elements, 30, 40. Okay. Now, let me draw the memory representation of the array. It's a continuous memory. So the index will be 0, 1, 2, 3, 4, 5, and 6, and so on. It's a continuous memory. But I have reserved only 4 elements. I have reserved only 4 elements. So I have initialized this array with 4 elements, that they are 10, 20, 30, 40. Okay. Suppose, right, if I print an element percentage d double quote comma arr of 0. If I write arr of 0, obviously I will get the output as 10. If I write arr of 1, I will get the output as 20. If I write arr of 2, I will get the output as 30. If I write arr of 3, I will get the output as 40. Now suppose if I write arr of 4, what will I get? So if I write arr of 4, don't you think I am trying to, right? The user is accessing beyond beyond range. So if you access beyond range, you will access these continuous memories. This is what you will access. So whenever the user accesses beyond range, he will get the output as one second now. He will get the output as garbage value. We don't know what value is stored in those memories, so we call it as garbage value. We call it as garbage value. So what I'm trying to convey here is, if the user is trying to access, fifth one is, if you access beyond range in array, it always gives us garbage value or junk value. We don't know what is that value, right? We don't know what is that value. So basically, garbage value or junk means old program data. We call it as previous program data, previous program data. We don't know what were their previous programs. We don't know them, right? So that data will be still present, will be still present in the memory. So that data we will access it. Now what we will do is we will go with the last scenario, right? Example 6. Okay, example 6. Now int ARR of 4, right, is equal to 10, 20, 30, 40, right? Okay. So here, right, in this point, if I printf double quote percentage d double quote comma ARR of 2. If I write ARR of 2, I will get the output as 30. If I write ARR of 3, I will get the output as 40. If I write ARR of 4, I will get garbage value or junk value. Correct? But if I write only name of array, if you write only name of the array, this will give you base address, right? Base address. This will give you base address. So what is the meaning of base address? Base address means address of first element. Address of first element of array. That is ARR of 0 means what? The first element, correct? So we will get the address of the first element. This is what is given by ARR. ARR will give you address of first element. Let Now let us write that point. So last 6 point is that, okay, last 6 point is, right? So name of array, right? Name of array gives base address, right? What is the meaning of base address? Base address means, right, address of first element, right? This is what it will give us. So these are the 6 fundamental points for arrays, right? These are the fundamental points that we need to remember for the arrays. Okay, next, going on to next, right? One of our friend was asking an example here. So let us take an example here. Okay, let us take an example. So I will declare one array int ARR of 5. Okay, so I need to store 5 elements in this one: 10, 20, 30, 40, and 50. So these are the 5 elements that I have stored into these memories. Okay, so let's draw the pictorial representation of this, right? 4 and 5. So let's give the indexing 0, 1, 2, 3, 4. Okay, and the elements are 10, 20, 30, 40, 50. Okay, now whatever discussion we are doing, we will do it with respect to 16-bit compiler. Whatever discussion we are gonna do now, we will do it with respect to 16-bit compiler. So in 16-bit compiler, the size of integer is 2 bytes. Okay, in 16-bit compiler, the size of integer is 2 bytes. Now, right, so this is a memory representation. This is memory representation. It's a sequential memory, correct? So to store one value of integer, to store one value of integer, how many bytes of memory is required in 16-bit compiler? To store one value of integer, Don't you think we require 2 bytes of memory? We require 2 bytes of memory. So let us start giving a addresses, right? Let's start giving a address for these memories. Let us assume, right? The starting address or the first element address is 1000. For the first element, if the starting address of the array is 1000, what will be the address of second element? The address of second element will be 1002. The address of second element will be 1002, and the address of third element will be 1004, and address of fourth element will be 1006, and the address of fifth element will be 1008. Sir, why it is 1000, why it is 1002, why it is 1004? I'll explain you now. Now, understand that to store only one value, to store only one value of integer, we require 2 bytes. Means 1000 is 1 byte and 1001 is another byte. So 2 bytes are required to store only one value 10. Since it is an integer number, since it is a integer number, right? Sorry, 1 second. I'll draw that memory. Since it is a array, sorry guys, these auto shapings. Yeah, finally. So these are the 2 bytes of memory I have. So if you look at the value of 10, it is in 2 bytes we have to write 0000, 0000, 000, 1010. This is how it is stored inside a memory. We require 2 bytes of memory to store one element of integer. So 1000 and 1001, these 2 bytes are used for storing one value. Obviously the next value will be stored from starting from 1002. That is why the addresses are 1000, 1002, 1004, 1006 and 1008. Are you clear on that part? This 8 bit is equal to 1 byte. Okay, and this 8 bit is again 1 byte. Total is 2 bytes, right? Now one of your friend was asking me about how to find the number of elements. So let's take another example, right? Another example. To find number of elements, if array is pre-initialized, pre-initialized. If array is already initialized, then how to find the number of elements, right? For example, right, let's take an array here. Let's take an array. 1 second. So let us take an array here. Int arr of 5, right, is equal to 10, 20, 30, 40 and 50. So these are the 5 elements stored inside the memory. Now, right, how to find the number of elements? That is the question we come across here, right? How to find the number of elements? So to find the number of elements, int n is equal to, right? Int n is equal to size of, there is a size of operator, size of arr, right, divided by size of, right, size of arr of 0, right? So what exactly these are, what exactly these things are? So when you say size of arr, this will give us total memory, total memory consumed by array. Size of ARR, if you write the array name and use size of operator on that, it will tell us how much memory is consumed by the array. Now please message me what is the total memory consumed by this array. How many bytes of memory it is. Don't tell me number of elements. Tell me how many bytes of memory is used. Message me that. Okay. Now the second part is ARR of 0. ARR of 0 means what? First element. ARR of 0 means first element. So this will give us size of first element. This will give us the size of first element. Now you find out, let's check what is your answer with respect to, right, the size of the array. Okay, so total memory consumed by the array is 10 divided by size of first element. Size of first element is what? It is an integer. So size of integer is 2. So therefore n value becomes 5. Sorry, n value becomes 5. This is how we find the size of the array or the number of elements if the array, if right, array is pre-initialized. It is required only if the array is already initialized, right? So there are some more parts are there, right, in the arrays that we have to understand. Okay, so let's see what exactly they are. Okay, so the next thing is, right, read how to read values from user from user, and store them into array, right? Store them into an array, right? So first thing we need to understand here is, right, first of all we need declaration. All the array declaration, right, all those declarations are required here. Variable declaration, then, right, we can read elements. First we need to read the size, and then we need to read elements. If I ask all of you to write down some numbers, now don't you think first question all of you will ask me is that, sir, how many numbers should I write? Then I will tell you write 5 numbers. Correct? So before you start reading the array elements, you should always know how many elements you have to read, right? That is the size of the array. That is the size of the array. That is called as the size of array. Okay, let's start working on it. Okay, so let's start with int main opening bracket. Okay, so what all variables are required? Int ARR of 50, right? ARR of 50. Then I need n value, int n. Okay, I need int n. So n will store what? This n will store the number of elements or the size of the array. Now, what is the first thing we should do? We should read the number of elements or read the size of the array. So, one second, I'll just draw the memory representation of array. Okay, I'm just drawing memory representation of the array. Okay, so the next thing here, continue. So once we declare all the things, so this memory ARR with 50 elements is reserved. I am reserving 50 memories. Maximum I can use is 50 memories. Okay. Now, next thing is I am declaring one variable called as n. Okay. Now, only if I know printf enter size of the array. So how do we get the size of the array, right? I need to use a scanf double quote percentage d double quote comma ampersand n. So this n variable, right, will store the number of elements. So let's say user has given 5 as a n size. He will enter 5 as a n value. Okay. Now, how many values should we read? If the user enters, right, n value as 5, how many values should we read in and store them into the array, right? If you want to, since the size is 5, if you want to read the values from the user and store them in a different memories like here, don't you think we need to generate these indexes to access a particular memory, right? So we need to generate all the index from 0 to 4. We need to generate, right, indexes from 0 to 4. So how do we do that, right? So generate, right, 0 to 4 index. If you know all these index, then only you can access those memories. So how do we generate 0, 1, 2, 3 and 4? Now don't you think these are sequential numbers? Starting from what index? Starting index is what? 0, right? So to access these or to generate these sequential memories, we need to write a for loop. For I is equal to 0, I less than n and I plus plus. So what exactly this loop is doing? This loop is generating sequential numbers starting from 0 till n minus 1. Are you understanding? The for loop what you have written is generating the indexes. It is generating the indexes starting from 0 till, right, size minus 1, that is n minus 1. Now, while generating indexes inside this loop, if I write a scanf double quote percentage d double quote comma ampersand arr of I, when the loop is executing for the first time, when the loop is executing first time, I value will be 0. So the first value user enters, that will be stored into arr of 0. So the value will be stored in this place, that is 10. It will be stored in this place, that is 10. Are you getting my point? Okay. Now when I value becomes 1 and the user will give the second input, right, user will give the second input as 20, so that 20 will be stored here. When the user, right, when the I value becomes 2, the user will give the third input and that third input will be stored in this place. And when the I value becomes 3, the user will give the fourth input, that is 40. It will be stored at this index, right, at index 3. And when the I value becomes 4, right, user will give the fifth value, which is a 50, and it will be stored at index 4. And when the I value becomes 5, now you check the condition 5 less than 5. What will happen here? The condition will fail and it will come out of the loop. And the loop what you have written, we call it as traversing an array. We call it as traversing array. So whenever you want to read array element, what we have to do is we need to traverse the array. Whenever we need to read the array elements, we need to traverse the array. So this is right reading, end of reading the array elements. So whenever you want to read array elements, you need to traverse the array first and then you have to read the values. Now continuing. The next part is right printing right array elements. Okay, printing array elements. Okay, so print how to print array elements. How to print array elements. So let's say my array is already initialized. So let's say int arr of 50, right? Sorry, not arr of 50. Let's take it as arr of 5 is equal to 10, 20, 30, 40 and 50. So my array is initialized with 5 elements. Then what I will do here is first thing I have to find is n value, number of elements. I need to know the number of elements for printing. So how do I do it? Size of ARR divided by size of, one second, divided by size of ARR of 0. Size ARR of 0. This will give us the number of elements. So I have an array which is already pre-initialized. Okay, I have an array which is pre-initialized. Total number of elements are 0, 1, 2, 3, 4, 10, 20, 30, 40, 50. Now, if I want to print all the elements, if I want to print all the elements of the array, first thing I should know is these indexes. I should generate the indexes. If you are generating an index, we need one I variable for the loop. We need one variable I for the loop. So now what we will do is if you want to print the array elements, right, for I is equal to 0, I less than n and I plus plus. What do you call this part? This for loop is called as traversing an array. Traversing an array. Traversing array. So whenever you are printing array elements, you need to traverse the array first and one by one element you take it out and print it. So write down the printf inside the for loop percentage d double quote comma arr of I. Arr of I. This will help you to print the array elements. Right? This will help you to print array elements. So are you clear on this part? Let us write a program to print and to read array elements. Okay, GDB online compiler. Let's use this online compiler for writing a code. Okay, okay. So let's start writing it. So first step is right. What is the job are we doing here? Read array elements. Read 5 array elements and print them. Okay. So first of all, first step is declare an array with some reserved memory. reserving 100 memories, right? Reserving 100 memories or 100 elements. Now I need one I variable for traversing, and I need one variable for storing number of elements or the size of the array. N is used for storing size of array, and I is used for traversing, right, array. Traversing in the means generating index. Traversing an array is nothing but generating index. Okay. Now once it is done, first print a message, enter size. Okay, put some message and then write a scanf and get the n value from the user. Okay, so you are reading the size, reading size of array. This is the first step in the array. Always you should get the number of elements first. Once you get the number of elements, then read array elements. Okay, so first print a message, enter array elements, right? So inside this, what we if this is a message we have printed. After that, if you want to read array element, what is the first job we have to do? We have to traverse the array. We have to traverse the array. This for loop, what we have written, it is called as traversing an array. Traversing an array. Inside this, what we have to do? We have to read the element percentage d double quote comma ampersand arr of I. So since there is only one statement inside the for loop, we can skip the braces also. We can skip the braces because there is only one statement in the for loop. Braces are optional. Or if you get confused, then keep it as of now till you become perfect. So once you finish reading elements, what is the next job? Print, right? Print array elements. Or what we will do is array elements are, array elements are slash n double quote. Okay. Now, if you want to print all the array elements, what is the first thing we should do? If you want to print all the array elements, what is the first thing we should do? We should access all the memories. To access all the memories, we should know the index. So we need to generate all indexes of those array memories. How do we do that? If you want to access all the memories of the array, you need to generate all the indexes. All the indexes can be generated using the for loop, which we call it as traversing an array. So whenever I ask you, right, what I have to do for printing array elements, you should say that, sir, traverse the array. You should say that, traverse the array. So while traversing, should I read or print now? Now, should I read the elements or should I print the elements? We should print the elements. Every element when I'm printing, after printing one element, I will give a tab space so that it looks neat. Then ARR of I, right? And this loop what you have written is called as traversing an array. Is everybody clear on this part? Let us execute and check. So do we have error? No. So let's give the size of the array as 5. So let's give 10, 30, 20, 40, 50. So we have read all the array elements and we are printing all the array elements. So once everybody is clear about these basics of arrays, now today will be the end of the session. In the next session, we will learn about, right? We will start working on array based programs. Okay. We will start working on array based programs. Thank you for today.